what is an exothermic, I will not be in a position of answering questions correctly in this specific chapter or this specific section. So the key idea was, how best can one know and how best can one understand exactly how and when to tell if a reaction is exothermic or endothermic? Because the whole topic, as it overlaps to grade 12, these are the key things that we need to know. We cannot answer questions before we fully understand whether it's exothermic or endothermic. So I am quickly going to try and do a summary for everybody and have now practice questions that we can look into. So let's start by saying, how can one know if a reaction is an exothermic reaction? We are told that an exothermic reaction is a reaction in which energy is lost or released. That is the key thing. And this one obviously is now an opposite, is a reaction in which energy is absorbed. So the statements here is that the examiner can tell me that the energy is released, or the examiner can also tell me that the energy is absorbed. So with that statement only, I am in a position of fully understanding and knowing that I am working with an exothermic reaction or endothermic reaction. Then point number 2 is now when the examiner says to me, delta H is less than 0. Delta H is now greater than 0. So when I am given delta H, remember this, it's very important. When I am given delta H, it's usually and not usually, it is for a forward reaction. So it basically says that delta H that I will see in a question paper, that I will see in my practice question, if I am given the delta H, it's actually the delta H for a forward reaction. Then we further say also this will be the same for endothermic. If I am given delta H, definitely the delta H will represent the forward reaction. So my forward reaction will be an endothermic reaction. Fine. That is now point number 2. Point number 3. They say now to me, the energy of the products. Energy of products is smaller than energy of reactants. Let's say smaller than energy of reactants. Fine. So when I am given a graph or a statement, and they say in this statement that the energy of the reactants is greater than the energy of the products, automatically that should tell me that I am working with an exothermic reaction. We further move on. So it basically says now energy of products in this case is greater than energy of reactants. Easy to understand. So we are now not being told that energy is absorbed. We are not being told that uh, delta H is greater than 0. But we are told that energy of the products is greater than energy of the reactants. Automatically, I should be in a position to associate this with endothermic reaction. Any questions so far? Any questions so far? If there are no questions, then let me quickly continue. Now, at number 4, we say now the energy to break the bonds. Energy to break the bonds. It's smaller than energy to form the bonds. 100%. And we further say now energy to break the bonds. To break the bonds is greater than energy to form the bonds. The bonds, it's now greater than energy to form the bonds. Form the bonds. So usually this type of a question they will ask now in your multiple question type of an exam. So it's information that we need to be looking for. It's information that each and every one of us must now try and understand. What else can one say in terms of this? One can easily say for exothermic reaction, energy is released into the environment. What does that mean in terms of the reaction vessel or the walls of the container? So if energy is released, it means now the reaction vessel, the reaction vessel, the temperature of the reaction vessel, or we can easily say the reaction vessel becomes hot. That is important. The reaction vessel becomes hot. And for endothermic, the reaction vessel becomes cold. Also very, very important for us now to understand. So I am told that the reaction vessel is getting cold. So if the reaction vessel is getting cold, then I know that I am working with an endothermic reaction. But now the examiner doesn't want to tell me all this nice information for me to understand. They give me an equation, which is now another way, A plus B, which gives me now AB, and the AB plus now also the NH. But now they also say they give me A plus B plus energy, and now this gives me AB. Can one be in a position of classifying reaction as exothermic and endothermic? 100% we should be able now to do so. The reason for that is when I have my reactant A plus B, it produces AB and it releases now the energy. So because the energy now is on the side of the products, it tells us that energy was released. The forward reaction is now exothermic. The energy of the products is less than energy of the reactants. The energy to break the bonds is less than the energy to form the bonds. And this is the reason why the reaction vessel becomes hot. Let's further move on. If we move on now to endothermic, I have reactant A plus B, but now I have my energy being part of the reactants, then it forms AB. So it basically says the reaction vessel will become hot, so it will become cold because now the energy is absorbed now to break the bonds. That is the reason why now the reaction vessel becomes cold. Last one. It's this one. The last one is just from now the shape of the graph. What is the shape of the graph? The shape of the graph is I will have my energy of the reactants. It will move up to there and decrease somewhere there. I will have now this one here move now up there and have my energy there. So let's try to label this simple sketch. Obviously, the reactants will be now our section where everything will start. So this becomes now energy of reactants. This one here becomes now energy of the products. This one here now becomes energy of the reactants. This one there becomes now energy of the products. But there are a lot of things that one can be in a position of understanding. What is it? We are told that delta H is actually equals to energy of the products minus now energy of the reactants. So what does this say? It says to me this part here will represent now my delta H. Why will it represent delta H? Because it is now the energy of the products minus energy of the reactants. Let me get a different color and say, how about now this side? What is it that is going to happen? This energy here, it is delta H for endothermic reaction. But there is something else also. What is something else? It is this part here which they call activated complex. And what is now activated complex? We said an activated complex is a transitional state between the formation of the bond and breaking of the bond to form the product. So if you have now challenges in terms of fully understanding what is an activated complex, kindly revisit now the notes that were shared with you on the previous session. So we will also have now our activated complex. And the other keyword now that we need to be looking for is the activation energy. Anyone who can help? What is an activation energy? Anyone?
Sir,
Yes, Lindiwe.
it's the minimum energy needed to allow a chemical reaction to occur.
Very true. It is the minimum energy needed for a reaction to take place. So these are keywords that we need now to look into. So activation energy, minimum energy needed for a reaction to take place. And now we have another key important word. What is now a catalyst? Anyone? Catalyst? Catalyst, ladies and gentlemen, what is a catalyst? Okay, now a catalyst is a substance that increases the rate of the reaction. Okay, let's read. A catalyst is a substance that increases the rate of reaction by lowering the activation energy. It basically that. So it's a substance, keyword also, substance that increases the rate of reaction by lowering the activation energy. That is now also very, very important. So now with this being said, Mpilo, with this being said, is basically a summary that I tried to develop for each and every one of us, for us to be in a position of when I take this session to the next level, each and every one of us will know exactly how to go about this. But I must emphasize, if you have identified the forward reaction as endothermic, the reverse reaction will be exothermic. It's always the case. So if you have identified the forward reaction as exothermic, then the reverse reaction will be endothermic. It's always the case. So it means in one graph, I can have the activation energy, which is here. Let me see if I can't duplicate this and increase now space for what I want to explain, because other questions comes now saying something about reverse and forward reaction. But like I said, the information that will be given to us will be the information for the forward reaction. So if I have information for the forward reaction, I can easily use that for me to get information of the reverse reaction. I am going to explain that now quickly for us to be in a position of fully understanding. So I'm trying to assist Mpilo also to catch up with everything that we have done. So any questions so far? Any questions? Any questions, guys? You guys are too quiet. I'm not sure if you're still in this session or not, but kindly say something just to notify me that you are still fine.
Still fine, sir. Thank you.
Thank you very
No
much.
question. Yes, sir. Still fine.
Thank you very much. Thank you very much. Then let's delete this. Just want to create space. Delete that. And select this. And also delete. Create space. And also delete. Select this. And just move it up here. Select this. And move it now up there. So I'm going to draw a nicer, bigger graph. Let's have this and that, have this and that, and we say this is the situation here, and we say this is the situation there. So let's label this graph of ours. This here, it will be our minimum energy needed to start a reaction. So that is now the activation energy.
Sir, I can't see the graph.
You can't see the graph.
Yes, sir.
Okay. There it comes.
Yes, now I can see it.
All right. Thank you. So it's the activation energy, ne? Can we also say this here will be the activation energy, because we agreed that activation energy will be the minimum energy needed, ne? So this is the activation energy. And let me take yellow and explain that this here we agreed it's our delta H. We take the yellow for this one. We agreed now that will be our delta H also. And furthermore, we said this is energy of the products, this is energy of the reactants, energy of the products, and energy of the reactants. But when we get into questions, we are going to be given a reaction which is A plus B with two arrows now that gives us AB. And the examiner will say delta H is smaller than 0. The very same examiner will do the same. A plus B giving us AB, but now delta H is equals to 12 kilojoules. Is equals to 12 kilojoules. So let's select this and move it up a little bit. So that is the information given to us. Delta H is positive, so it's greater than 0. But what possible questions can come from this? 1. When you see a double arrow, it says you have 2 reactions taking place. So these 2 reactions that are taking place here, it's your exo and now endo. The same there. You are going to have your endo and you are also going to have the exo. So once you see a double arrow, remember that both reactions are taking place. But on the first slide, what did we say? We said on the first slide that delta H that will be given is for the forward reaction. So when I have these 2 graphs or these 2 reactions taking place, basically because I am given delta H here, this delta H and that delta H. So what does it say to me? It says definitely I know that the forward reaction must be endothermic. If I am looking at this one, because delta H is less than 0, I definitely know that the forward reaction must now be what? Exothermic. So because of that, I can confidently come back and say, fine, because of that information, the forward reaction is now what? Exothermic. And then the reverse reaction will now be what? My endothermic. So every time when the forward reaction is an exothermic, the reverse must be endothermic. So it comes to this also. Because of delta H is greater than 0 because we have 12 kilojoules, it says now I can confidently say the forward reaction is now what? Endothermic. And then this one here, it basically says the reverse reaction will now also be an exothermic. So when you are asked such a question and you have double arrows, just remember that 2 reactions are taking place, the forward reaction and the reverse reaction. But the information given will be for the forward reaction. So once you have identified that your forward reaction is endo, then the reverse reaction must be exo. 100%. Any questions relating to this?
No, sir.
Okay, then let me give you 50 seconds breather for you now to digest everything. Thank you very much. Then it basically says we can continue and move on. Now, if I have the graph as it is, so this graph, everything here is basically for the forward reaction. The graph given the graph given is for the forward reaction. So everything here is basically for the forward reaction. So when I am asked to identify the activation energy for the forward reaction, it's easy because it will be from this point to that point. But if I am asked now to identify the activation energy for the reverse reaction, it should be this one here. So it should be activation energy for the reverse reaction. So that is how this basically works. So this is now for the reverse reaction. So in one graph, you have an activation energy for the forward, and then you have an activation energy for the reverse. That is now always the case. So activation energy for the forward reaction, and now activation energy for the reverse reaction. So that allows us to know and answer whichever question that may come along the way, or when we do now the exam type of question. So I have a question that I want us to do together as a basis of ensuring that the basics are understood. So remember, you will still get now the PDF notes as promised, the e-notes. So the e-notes is just now trying to save you time such that you can have more time to practice. Because remember, you can have all the nice notes and everything. If you don't try to go an extra mile, we will not get the desired results. Let's look at this number 6. I want to try and have a spotlight. Let me increase the spotlight. Okay, let's close that. Delete. I am trying to add a nicer thing here. Nope. Spotlight. Okay, let's have a whiteboard and check. It's not assisting. Let's delete. Let's have a spotlight. It's also not assisting. It's fine. Because what I wanted us to do, maybe I should do this and fill it with yellow, and maybe fill it with black. Not assisting also. Okay, it's fine. You guys survived. Now the idea was, I want us to scrutinize the graph without actually looking into without actually us looking into without us looking into the questions, because what we normally do is we are quick to answer without really understanding what we want to achieve. So I think I got it right this time. Then I must just change the color to black. But you guys can still see. Let's see. It's not nice and beautiful. Nice and beautiful. Nice and beautiful. So I don't know what are the questions, but I am told that here is the graph. So I want all of you to open your mics, and we are going to interrogate this graph to a point that somebody must say something about this graph. We don't know the questions. We are only interrogating the graph. So interrogating the graph basically says, what can we say about this graph? I don't have answers. I don't know the questions. I am only trying to understand from the statement only, or from the graph given, am I in a position of saying a nice and lots of things relating to this? Anyone?
So can I try?
Yes, Mpilo.
Is the 166 kilojoules our activation for the reverse reaction?
Okay. You say it is an activation energy for the reverse, but now check what is the trick. If it was for the reverse, remember it must now start from the product up to there. So where does this one start? It is starting at the reactants to the activation complex. So it basically says this here now becomes what? Our activation energy. So the
So,
activation energy is actually 166 kilojoules for the forward reaction. Can you see that?
Yes, I can see.
Because now for us to say the activation energy for the reverse, then it must start at the product. So this will be now our activation energy for forward, for the reverse, for the reverse reaction. So can you see, with just one mistake, everything will now start to fall off and we will not be in a good position of answering. Can somebody say something related to this graph?
sir,
Yes, Lindiwe.
we can see that this graph
Othniel, you can switch off
is
here for now.
an exothermic
So it is an exothermic reaction.
reaction. Yes.
100%. We say it is an exothermic reaction. Can you support that?
Because The reactions, the reactions,
The
uh,
reactants, yes.
yeah, the reactants are bigger than the products.
Okay, so energy of reactants is greater than energy of products.
Yes, sir.
Okay, now somebody else must also come and say something quickly, 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 quickly. What else can you say? Something else? Somebody? I will come in and help you to say this here should be my delta H, because I know delta H is now the difference in the energy of the products and reactants. Happy with that. What else can we say? A lot of things, but for now, I think this is more than enough. Let's delete this. We have something also to delete here. Oh, I have this. Let's undo it. Fine. Okay, let's choose now a pen. And then we are covered. Let's check the questions. What is the activation energy for the forward reaction? Can you see that we already answered that? So it's easy for us to say the answer should be 166. Ne? So we did
So,
not, yes, I am listening.
no, sir, I'm not asking a question.
Oh, okay. I'm at 6.1. Ne? What is the activation energy for the forward reaction? We agreed it must be 166 kilojoules. Then you get your nice 1 mark for that. By just interrogating the graph, we are in a position of trying to get the correct answers. Now, what is the other thing happening here? What is the delta H for the forward reaction? Delta H is now negative ne? 21 kilojoules. Can somebody emphasize why did I decide to add the negative there?
So, because it is an exothermic reaction.
100%. Because it is an exothermic reaction, I am expecting now my delta H to be less than 0. So if you did not have that negative, you are going to get it wrong. So it's now the emphasis of saying this is now an exothermic reaction. So the table we had of that summary of how to compare, it's now coming into play. It's now assisting us fully. Is the reverse reaction exothermic or endothermic? I need an answer. Is the reverse reaction exothermic or endothermic? The reverse.
It's endosemic.
100% it is endothermic, because we agreed that for the graph we get, we are going to know it's a graph of the forward reaction. So if the forward reaction is exothermic, the reverse reaction must be endothermic. So it's another mark there, another mark. What is the activation energy of the reverse reaction? Hmm. Hmm. I need an answer. And how do we go about this one? the activation energy of the reverse reaction. We agreed that now this part or this section here, it is the section of what? The activation energy of the reverse. So how can we get now the total energy of this energy or the activation energy of the reverse reaction? What can we do? Because I see that my energy is starting at 2hi up to the energy of the products or the activated complex. So how about I add 166 together with the 21, because most from 2, let me get a pen, let me use purple. Let's see if we can get a laser pen. Let's get a laser pen. Sorry. Let's get a laser pen that will flash. Because here I have the 166 and the 21. So the 166 plus the 21 should give me the activation energy for the reverse. Do we agree?
Yes.
Yes, sir.
Yes. So it says to me, fine. Then because I understand exactly the graph, it's easy for me to say I am going to have 166. Okay, let me write a smaller formula. Activation energy of reverse reaction is equals to 166 plus 21 is equals to, let me quickly get my calculator. Do I have one here? I think I do. Let's check if I have. Indeed, I have a calculator. So it is 166 plus 21 is equals to 187. So 187 kilojoules. Any questions with this one? Okay, if there are no questions, thank you very much. And then this one will most probably be 2 marks for adding the 2 and getting the final answer with the correct SI unit. Now listen for this. How will a catalyst influence the reaction? Now we said when we have a catalyst is a substance that increases the rate of reaction by lowering the activation energy. So because of that, the catalyst will influence the rate of the reaction or how quick the reaction is going to occur. So this already is the answer. Because now, how will a catalyst influence the reaction? Bullet number 1, a catalyst will increase the rate of the reaction. Increase the rate of reaction, comma, by lowering the activation energy. So it's actually lowering the activation energy. That is how it is doing it. Without, it's important, without undergoing any permanent change. Full stop. And then that is your now nice 2 marks. So this was just a basic example that we need now to be looking into. Can somebody now ask any question related to this? Is everything clear? Do you understand on these basic concepts? So we are going to take this basic concept together with the table into the exam type of equation. So I want you to ask questions, and if you don't have questions, then you clearly state to me that we don't have questions and we can proceed. But before that, I am going to give you now another 50 seconds for you to digest everything. And then if after 50 seconds there are no questions, then I will definitely proceed to the next one. Yes, of Neil?
Yes, sir. On the graph, on
Yes.
which point is the energy reactant?
Energy of the reactants.
Yes, sir.
Okay. Let me highlight it for you. Let me take this. It's here, big brother. I'm trying to make it bigger for you. Let me make it bigger. On the graph, it's there. Here,
Okay,
this
okay.
section here. Why can I be certain, or how will I be certain? Check here. The reaction is between I2 plus H2. Can you see that?
Yes, sir.
So those are my reactants. And then somewhere here, I have 2HI, and I have 2HI, which is now on the right. That basically says that is now my product.
Right.
So hence I can easily know where and which part in the graph represent the reactants or energy of the reactants or of the product thereof.
Okay, I see, sir.
Thank you very much.
Thank you,
Now,
thank you.
thank you, Ntate. So with that being said, let's move to this one.
So I have a question.
You have a question. Thank you very much. Yes, Impilo?
So question 6.4, is that how we're always going to answer the question, even if it was endothermic?
100%.
Okay. So there's no
100%.
equation whatsoever.
There is no equation. You just use your standard way of understanding the graph. There is no equation. The only equation we have in this section, let me get a pen, is delta H is equals to EP for the products minus E for the reactant. This is the only equation you are going to have. The other ones, honestly, it will be just on you as to how you understand the graph, basically. Because some people, what they normally did in the previous questions or trying to formulate a word on how to answer this, they ended up not having right answers because of trying to derive the formulas. So for me, what works best is, because there is no formula in the formula sheet that relates to activation energy. There will be no mark for that. The only mark will be given for the formula that is now in the formula sheet. So why worry about an equation that is not in the formula sheet? Focus on ensuring you understand the concept of how to calculate activation energy.
Okay, so when do we use this equation?
It's not an equation, it's just a
The
standard.
delta H. The one with the
Delta
delta
H.
H. Yes.
Okay. We are going to use it very soon. Let's just pause it there and then we build on it moving forward. Thank you. Now let's move to this one. Let's move to this one. And let's read the question. You'll have one to do, don't worry. For now, we are trying to exercise the mind and see if all the concepts that we've been doing are true. They say now, a barium hydroxide solution reacts with nitric acid solution according to the following equation. The potential energy of the graph shows the change in potential energy for this reaction. I wish I could have started by saying, what if we don't have questions? What can we say here? Let's see if that will work. Let's cover this. Let's cover it and ensure that you don't see anything. The assumption is I don't have any questions, but I need to interpret the graph. What can we say about this graph? Anyone?
So it is an exothermic reaction.
Okay, sorry. One, below is saying it's exothermic. Okay, exothermic. Why below?
So our reactants are more than our product.
Okay, so we have reactants, ER being greater than EP. Okay. And then what else? What else can we say about this graph before actually even thinking of answering the questions? What can one say? Can I say?
116 is our delta H.
Okay, then we have the 116, that is now our delta H. And then what else can we say?
So I have a question.
Yes.
So on the equation, it's A plus B, but then there is no energy that is on the equation or after the reaction.
Because they've given you the graph again.
Oh.
Yes, so why give you delta H at the top and give you a graph? Yes, so remember it's either that delta H for you to know or the graph for you to know, so that you'll be able to answer questions. So some form of a hint should be given.
Understand.
All right. Then what can we say now with this graph? Anything else? Anything else? I can say this part here is what?
Activation energy.
Activation
Thank you
energy
very
for the
much.
forward motion.
For the forward reaction, activation energy for forward, 100%. And then this one here, now activation energy
For reverse.
for reverse. Thank you very much, brother of me. And then I can say this one here, it is my activation, activated
Activated complex.
complex. Very good. So let's look into the questions. We tried now analyzing everything. Check. Is the reaction endothermic or exothermic? Done. Exothermic. Give a reason for your answer. Energy of the product is of the reactants is greater than energy of the products. Ne? So we can also add that energy is released just to give it more body. Energy is released. Full stop. 2 marks. And that reason also of energy of the reactant is greater than energy of the products, we will also accept. Now, use energy values A, B, and C to indicate on the graph and write down the expression for each of the following. So what are they saying? They are saying to me, I must use A, B, C to write an expression. So the energy of the activated complex, which letter represents that?
Letter A.
Letter A, 100% 1 mark. Which letter represents now activation energy for the forward reaction?
AB.
AB. What if I say BA?
So
Am I wrong to say so?
is it not the same?
I don't know, but we'll agree that for the purpose of alphabetical order, it's AB. But even if you write BC, BA, I will still give you a mark. I don't have a problem with that because basically it's just the range between A and B and then between B and A. So it doesn't really matter, to be honest enough. Now, delta H for the reverse reaction. Delta H for the reverse reaction.
AC.
Delta H, not the activation energy. Remember, the activation energy is starting there at C, moving all the way to AC. That is now the activation energy for the reverse reaction. But we are interested in delta H.
BC.
BC 100%. So now let me emphasize this. For exothermic or endothermic, the only delta H, okay, the only thing that will differ, okay, the only thing that will be the same will be delta H, regardless whether it is for endothermic or exothermic. The only thing that will change, it's the sign. Maybe let's say this question was saying delta H for the forward reaction. The answer will be negative 116 kilojoules per mole. Ne? Because of this. Because we are interested in having an exothermic reaction. But now for this, it will just be 116 kilojoules per mole. So this will mean now it is for the endo, which is the reverse. And this will now be for the exo, which is the forward. So basically the value, regardless whether endothermic or exothermic, will be the same. The only thing that will change will be the negative side. So I want you now to take note of that. So it basically says to me, even if the question was the activation delta H for the reverse reaction, it will still be BC. The delta H for forward reaction, it will still be BC. But if they wanted a value now, a magnitude, and they wanted for reverse, I should have told them that it must be positive 116. Because if it's not positive now, it becomes a negative and it becomes an exothermic. So if the question here was the value of delta H for the forward, then I must add the negative to indicate that the forward is now what? An exothermic reaction. Any questions, ladies and gentlemen?
Sir, I have a question.
Yes, Mpilo.
So for question 7.2.3, if I didn't write BC but wrote 116, was my answer going to be wrong?
Yes, it was going to be wrong. Let's read the instruction. Use values, energy values A, B, and C. Do you see that? So try by all means to follow the instructions of the examiner. It's like when the examiner says, draw a free body diagram, and then you draw a force diagram. So it basically says you did not follow the instruction, then we need to penalize you somehow. And it's like you saying, if the question at 7.23 was, give the value or what is the value of delta H for the reverse reaction, and then you write BC. That is not the value, Mos. Then it basically says we must penalize you. So let's try by all means to stick to the instructions of the examiner. By so doing, we know that we are not going to be penalized, but we'll actually get the maximum marks. Any questions, ladies and gentlemen?
No, sir.
No, sir.
Thank you. Thank you very much. Then we can have our timer for the 50 seconds for each and every one of us to digest this. Thank you very much. If there are no questions, then we can move to this one. So this one, I'm going to give you some time. Let me check what time is it. It's 19:20. So I'm going to give you something like 4 minutes for you to do it. Remember to take a picture, send it directly to me, and I will quickly mark it and give you an immediate feedback, and then we'll be left with 6 minutes to discuss this. So your time starts now. Thank you. I haven't received anything. Does this mean you need more time?
Yes, sir, 1 minute.
Yes, please.
Okay. I got 1 minute. So I will make it 1 minute 30 seconds. Okay. I found answers. Okay, one from Mpilo. Let me quickly mark this one. Okay, 1, 2. Done, sent. And then there's one from Lindy Way. Thank you, Othniel. You also received one. Okay. Okay. Done, sent. And then we go to Othniel. There we are. Go and edit. 1, 2, 1, 2. Done and sent. I think you should have got your feedback by now. Yes. Let's quickly look into it. Most of you got the definition right. The definition for activation energy, that was an easy one for you to get marks. It's easy. It basically says it's just the minimum energy needed for reaction to take place. Nice, 2 marks. It's now the combustion reaction of butane or endothermic. What is a hint here? The hint is this delta H that is given there. Delta H that is given Mpilo. You did not check any information that will be a hint for us to know whether the reaction is exothermic or endothermic. You forgot about the table of how and when can one decide whether the reaction is endothermic or exothermic. So because of this, one can easily say the correct answer here must be exothermic. At delta H less than 0 on energy is released. Very now easy. Draw a sketch of the potential versus cause of reaction for the reaction above. The fact that we have agreed, that this is going to be an exothermic reaction, it's very easy for one to be now in a position of drawing the correct graph. The fact is they want us to have the activation energy, heat of reactants, energy of reactants, or the graph of the products. So because we agreed that this is now an exothermic, so it will be easy to do so. So Mpilo, you took your answer for endothermic and then you went down with it. So can you see if this now becomes wrong at 7.2, everything else becomes wrong. So let's be careful of that. Hence, I said everything that we do, once we are in a position of securing the fact and ensuring that the reaction is exothermic or endothermic, then we will know I am going to draw this type of a graph and have that. Then this will be now my reactants. This will be my products. And what else do they want? The activation energy. Then I will have these dots here and have that space here and label it the activation energy. And have these dots here now and label this now my delta H. By so doing, then I have done everything that this examiner wanted me to attend to. So the challenge is they can either give you a graph. You saw question number 1, it was a graph and questions that followed. Then this one was also a graph. This one now, it's a reaction, but we are told that delta H is smaller than 0 and we are expected to draw the graph. We will do more closer to when we revise,